All right, hello everybody. Sorry, I'm not there today. This is the second part of my training that I had to go to. So today what we're going to learn about, it's called the Hinge Theorem. So you're going to take your notes in class and they'll be posted on Canvas with the video, so in case you miss anything. And then you'll have your assignment and that's going to be due Thursday. So first thing we need to start our lesson is to write down the Hinge Theorem and its converse. So the Hinge Theorem. It's if two sides of one triangle are congruent to two sides of another triangle, and the included angles are not congruent, then the longer third side is opposite the larger of the two angles. So what all that means is if you look at our two triangles here, triangle ABC and triangle ZXY. Okay, if you look, sides AB and ZX, they're congruent. And then also AC and ZY, they're congruent. So we have two triangles and they both have two congruent sides. Now, the included angles, those are the angles that are between our two sides. So that would be angle A and angle Z. Okay, and angle A is 50 degrees and angle Z is 80. So the side that is across from them would be side BC for triangle ABC, or side XY for triangle ZXY. And if you look at the angles, well, angle A is 50, whereas angle Z is 80. If you go across, then side XY has to be bigger than side BC because angle Z is bigger than angle A. So basically, if two of the sides are the same, you look at their angles that are between the two congruent sides. Whichever one has the bigger angle, well, across from it, that's the bigger side. So in this case, BC is greater than XY. So that's the Hinge theorem. Again, if you didn't finish writing all this down, pause the video, and then everyone writes it, and then when y'all are all ready, then you go on. Okay, the next one, it's the converse of the Hinge theorem. Okay, so this is just going the other way around. If two sides of two triangles are congruent, and their third sides have different lengths, then the larger included angle is across from the larger third side. So we're just going the other way around. So we see here we have triangle ABC and triangle ZYX. If you look at the two sides, we have AB and ZX are congruent, and AC and ZY, they're congruent. So we have those two congruent sides. Now look at side BC and side XY, because this is the key part here. BC is 8, whereas XY is 10. So if you look at the angles that are across from them, well, your longer third side is going to have a bigger angle. So since 10 is greater than 8, angle Z is greater than angle A. So that's the regular Hinge theorem, and now the converse. And again, if you need to pause the video, please pause it, let everyone write it, and then continue on. Okay, now we will go on to the examples. Okay, so here's the examples. It says, compare the lengths of SK and YU. Okay, SK and YU. So look at the angles that are across from them. Okay, because both of our triangles have the two congruent sides, and now look at the angles across. Angle A is 90 degrees, whereas angle O is 70. So whichever side is across from the bigger angle is the bigger side. So SK is across from the 90, so SK is greater than YU. Okay, next part here. Example 2. It says compare the measure of segment LN and segment OQ. So LN is right here and OQ is right here. Again, go and look at their angles. LN is across from a 125 degree angle, whereas OQ is across from a 78-degree angle. Whichever one is across from the bigger angle is the bigger side. So LN is greater than OQ. Okay, the next one here. It says compare the lengths of segment ST and segment BC. So ST is right here, and it's part of this triangle. So we can see that it's across from the 35-degree angle. And then you have triangle BC. So that's this one. And we can see it's across from the 30-degree angle. So again, your bigger side is across from the bigger angle. So 35 is bigger, so ST is greater than BC. All right, example 4. Write the inequality relating the measure of angle M and the measure of angle R. Okay, so here's angle R and there's angle M. Look at the sides across from them. Angle R is across from a side that's 7. Angle M is across from a side that's 8. So the one that's across from the larger side is the bigger angle. So the measure of angle M is greater than the measure of angle R. Okay, example 4. It says, what is the range of possible values for x? Okay, x is with this angle here. So you have to look. This 60-degree angle is across from a side that's 15. This 5x minus 20-degree angle is across from a side that is 10. Now, since the 60-degree angle is across from the bigger side, we know that 5x minus 20 has to be less than 60. Now, the angle also has to be positive, so this one has to be greater than 0. So anytime you're doing these, you have to do the angle is greater than 0, but then less than whatever the other one is. So now we just solve this. It's a compound inequality. So we're going to add 20. So I'm going to add 20 to everything here. Okay. So 20, and we saw the 5x, and 60 plus 20 is 80. And then now divide by 5. So x has to be greater than 4, but less than 16. And so that's how you do the range ones. So again, it has to be less than 16 because it's across from a smaller side. That has to be greater than 0 because obviously this can't be a 0-degree angle. So that's all there is to it for the Hinge theorem. And again, if you need to watch the video again, this is posted on Canvas, as are the completed notes. YouTube has many channels. Just type in Hinge theorem or Converse of the Hinge theorem. And make sure you've got these definitions down. And then you'll be good. I'll see you guys tomorrow.